Hi guys, so today we're going to be solving the standard equation of a circle given the general equation ax squared plus ay squared plus bx plus ey plus f equals 0. Now, in order for us to arrive with the standard equation x minus h squared plus y minus k squared equals r squared, we will use a method called completing the squares. So we will use this one to generate these two binomials on the left side of the equation. Let's now use completing the squares on the first problem. In the first problem, we have x squared plus y squared minus 10x plus 8y plus 32 equals 0 as our general equation. We are asked here to find the standard equation, coordinates of the center, and the radius of the circle. So to start, we will need to rearrange the terms of our general equation. So I will start by writing down the term containing x squared, followed by the term containing x, that is negative 10x, plus the term containing y squared, that's y squared. Then followed by the term containing y, that is positive 8y. Then for our constant, I will transpose that one to the right side of the equation, thereby making it equal to negative 32. Now the next step, we will need to convert these two quadratic equation into a perfect square binomial, and to do that, we will need to apply or to add a constant term to each of them. So I will rewrite the first constant term into x squared minus 10x plus the unknown constant term. We will do the same for the second quadratic. I would rewrite this as y squared plus 8y plus the second constant term, then equal to negative 32. Then whatever we add on the left side must also be added to the right side of the equation so that we can balance the equation. Now to solve for the constant terms here, for the first quadratic, what we will do is we will take the coefficient of the middle term, that is negative 10, divide it by 2, then square its answer. So I will have here negative 10 over 2 is negative 5. Negative 5 squared would be positive 25. So I will place here positive 25 on the left side and also positive 25 on the right side. Now for the second quadratic, the coefficient of the middle term is 8. So I will take 8, divide it by 2, then square its answer. So 8 over 2 is 4. 4 squared is 16. So I'll place 16 here and also 16 on the right side of the equation. And the next step here is to convert these two quadratic equations into a binomial. So to do that, I would have the square root of x squared, that would be x. Copy the sign of the middle term, that is minus. Then take the square root of 25, so that would be 5. Then place an exponent of 2. We will do the same steps on the second quadratic. I will take the square root of y squared, that is y. Copy the sign of the middle term, that is plus. Then square root of 16 is 4. Then place an exponent of 2. As for the right side, we will just need to simplify them. 25 plus 16 is 41. So 41 minus 32, that would be positive 9. So x minus 5 squared plus y plus 4 squared equals 9 is already our standard equation. Now for the coordinates of the center, we will just need to compare this standard equation we've solved with the standard equation of the circle. So by comparing, so x minus h squared plus y minus k squared equals r squared. So we can say that the coordinate of the center hk is equivalent to or is equal to, for h, that would be positive since they have the same sign, and for k, that would be negative 4 since they have opposite signs. Or what I just did here is I've just flipped the sign of negative 5 and 4. So hk would be 5, negative 4. As for our radius, we will just equate r squared here and 9. So therefore, our radius here would be equal to 3. So this is now our center and our radius. Let's now solve problem number 2, wherein the coefficient of x squared and y squared is not equal to 1. So we have here the general equation 2x squared plus 2y squared minus 16x plus 4y plus 20 equals 0. So for its solution, we would need to divide first all the terms of the general equation by the coefficient of x squared and y squared, so that it would be easy for us to perform completing the squares. So our general equation here would be 2x squared divided by 2 plus 2y squared divided by 2 minus 16x divided by 2 plus 4y divided by 2 plus 20 divided by 2 equals 0. Simplifying the left side of the equation, I would have x squared plus y squared and minus 16 over 2x, that would be negative 8x, 4 over 2y, so that would be 2y, and 20 over 2, that would be positive 10 equals 0. So we now have our simplified general equation. So we can now rearrange the term so that x squared will go first, followed by negative 8x, then positive y squared, then 2y, then as for the constant term, we will transpose that one to the right side of the equation. So we now have our two quadratic equations. We'll need to supply them with a constant term. So I will rewrite them as x squared minus 8x plus the first constant term, followed by y squared plus 2y plus the second constant term, equal to negative 10 plus the two constant terms. So to solve for the first constant term, I will take the coefficient of the middle term, so negative 8 divided by 2, then squared, so that will be negative 4 squared, that is 16. So I will place here 16, then 16 on this right side of the equation. As for the second constant term, I will take the coefficient of the middle term 2, divided by 2, then square its answer. I will have 2 over 2, that is 1. 1 squared is also 1. So I will place here 1, then also 1 on the right side of the equation. So next is we will need to convert this quadratic equation into its binomial form. So to do that, take the square root of x squared, that is x, copy the sign of the middle term, that is minus, then square root of 16 is 4, then place an exponent of 2. For the second quadratic, I will have square root of y squared, that is y, copy the sign of the middle term, plus square root of 1 is 1, then place an exponent of 2. On the right side of the equation, negative 10 plus 16 is 6, plus 1, so that would be 7. So this is now our standard equation. Now, to solve for the center and the radius of the circle, let's compare this one to x minus h squared plus y minus k squared equals r squared. So to determine the coordinates of the center hk, so what you will do is you will just change the sign of these two values. So our hk here would be positive 4 and k would be negative 1. So this is now the coordinate of the center of the circle. As for the radius, we will just equate r squared with 7. Then taking the square root on both sides, so the radius of the circle here would be equal to the square root of 7.